So to answer the first question about relative and cumulative frequencies, you can take a look at the two boxes. Okay, the top box is when you have all your participants, and you'll see frequency, which it can also be called count, percentage, valid percentage, and cumulative. And you'll notice that on the male is 56.3 all the way across, and then it's 44.3, and then 100%. I don't know why the 100% is there, but it's these two right here. If you look at this in terms of cumulative, in terms of cumulative, there's 56, and then you add in the 43, it becomes 100%. Okay. But if you're looking at these two, they're different. And the reason is you have missing variables. Talked about this in the Zoom a little bit. So you have this is the correct percent if you have everybody. And then this percent here is when you're missing someone. Okay. So there's only 93.8 reported out of the 100. So these, you kind of don't use these right here. The valid percent is over here, but these values change, and you would report this is male 9 in parentheses 56.3%, close parentheses, same thing 6, 35.7, and then you would go missing 1, 6.3. That gives you your relative. Okay, cumulative is when you have everything and it's over here. But these are the two lines. These are going to be the same if you're not missing anybody. If you're missing something, now your valid percent changes here. Second big question came up was, when will frequencies be used? In terms of this question, there's two different areas. One is just to look at what the participant's makeup is. Without that participant makeup, there's not really much you can do with the questions that you're going to ask. Plus, you can't run a lot of the tests because you need the demographics to run against that test. Okay? We go from a one sample to independent sample to ANOVA, and then you go into advanced statistics after that and correlation. And each of them run on different aspects. Knowing which ones they are the most important. So I'm going to go to 2 weeks out and say independent sample. Yes, you're using it to the makeup of the individual, but now you're taking that demographic of, let's say, or frequency that you have of male and female. You already know the breakup of it, but you don't know how it runs against something else. And that's what statistics is all about. And you're analyzing at best that. Test scores. You're taking a test in this class. I can take all the males and all the females, and I can run an independent sample to see who did better on what test. And then I'm looking for the difference. We're going back to difference now. Not an effect, but more of a difference. Okay, between males and females. So that's how it is. It's two things. One, it's all about the makeup of the people, and then it's going to be run in some of your testing in different arenas of different types of tests based on the number of answers that you're getting. So let's say socioeconomic has 3. It's in an ANOVA. You have 2. It's in what do you call it? It's in the independent samples t-test. And if you're looking at 1, you're basically looking at a number, and I'm getting into that next week. I'm not going to go too long. So understand that those demographics and frequencies are used later on in your testing to decide one of two things. Is one different than the other? And if that difference creates a choice that you need to make to fix something or keep it status quo.